Hello everyone, Namaskar. Now we are in the last lecture of the course. Today it is the summary of the course. We will sum up the course what we discussed during the entire course. So, let's discuss today that about post harvest management and processing. We need to look the challenges as opportunities. Then what are the ways forward, like what should be done. Entrepreneurship and startup also I will elaborate briefly, and then toward the end we will discuss about some other things, R&D activities in my laboratory, that is Food Chemistry and Technology Laboratory at IIT Kharagpur. Okay. You know, the India is a global sourcing hub. It is seen as a global sourcing hub. There are about 20 agroclimatic zones conditions, okay, 52% cultivable land, 46 out of total 60 soil types available in the India. India is the second largest food producer in the world, 7th largest in the area, and it has a very long coastline. There are about 31% consumption basket spending on food, 7.68% of the total global agriculture output, and more than that is the food and grocery has more than 60% of the India's retail sector, and that is the 2014 data. And food processing sector, agriculture and food processing, particularly the food processing, it is expected if everything goes as per the plan, by 2024 it will employ 9 million people, that is in the food processing sector. So, all these data shows that there are huge opportunities in agriculture and food sector in India. Let us discuss the agri-food ecosystem. Okay. That is a food processing. It involves right from the crop production till it comes on the consumer table. The food has to undergo in the different stages where various operators are involved, like that is the food producers, then primary food producers, manufacturers, secondary manufacturers, wholesalers, etc., or retailers, food service operators, caterers, etc. All right, and these are the food manufacturing company. They have to make a proper balance, and each and every stage adopt standard practices, standard operations, okay, to take care, that is they should take care of the statutory and regulatory body on one hand, and then consumers preferences, consumer demands on the other hand. Okay. So, this whole makes the agri-food ecosystem. If we look at the agriculture food sectors, what are the various sectors in agriculture? We can divide it into 5 major categories. One is the durable crop sectors, which includes grain, cereals, legumes, oilseeds, etc. Then perishable sector, that is fruits, vegetables, dairy products, meat, fish and poultry. Third category may be commercial crop sector, which includes tea, coffee, cocoa, so on. And then there is another sector which is considered, that is unexplored or underutilized crop sector, like non-timber forest produces millets, and finally the health value crops, which includes spices, condiments, or many health and beneficial fruits and vegetables. So, in this course we considered mainly in the perishable food, fruits and vegetables, in the commercial crop sector, tea, coffee, cocoa, etc., and the health value crops like spices, condiments, and other beneficial fruits and vegetables. So, and this constitute a major section of the agriculture and food sector. So, that we covered in this lecture. So, all these sectors, they have major challenges, that is different sectors have different challenges. So, I will just take here the 3 sectors which we covered in this course, like fruits and vegetables. So, major challenges that how to increase their shelf life, because they have short shelf life and they are perishable in nature. So, there is a fast deterioration of nutritional and sensory characteristics. There are lack of modern harvesting and cold storage infrastructure, modern harvesting practices, etc., are inappropriate post harvest management. So, these are the major challenges to solve in the fruits and vegetable sector. If you look at the health value crop sector, there are lack of technical skill, toxicity of residual agrochemical used for pest management, lack of value addition and quality upgradation, and improper post harvest practices. In the commercial crop sector, climatic hazards, prevalence of diseases and pests, difficulties in clearing of dense vegetable cover, and soil erosion due to over exploitation. So, these are the some of the challenges. Okay. So, that is the in the post harvest that management in the fruits, vegetables, etc., that is the reducing the supply chain losses are the major, because in the earlier, if you remember the first lecture when we discussed, that is in these categories huge losses are there. In fact, in fruits, vegetable, in some cases up to about as high as 35 to 40% losses are there in perishable. So, these supply chain, in the supply chain of a produce, there are 2 stages, that is the upstream like agriculture, which involves production, post harvest handling and storage, and the downstream you can consider the processing and packaging, and then finally distribution and consumption. So, the planned processing infrastructure in the upstream and efficient processing, storage and distribution in the downstream are the appropriate or best strategies to reduce the supply chain losses, and that is very important as far as the consumption and utilization of fruits and vegetables are concerned. So, as I told you, let us discuss, that is the post harvest management. Here one has to take these challenges as opportunities. So, what are the various areas in the post harvest management with new opportunities, like farm level processing. Here one should promote more and more venture for minimal processing of fruits and vegetable at farm level. Minimal processing means grading, sorting, etc., packaging. Okay. Then local manufacture of primary processing machineries, very important, that is the in the Make in India concept. So, for this farm level processing, that manufacture machines, etc., should be encouraged. Then cold chain and preservation infrastructure facilities are to be without any break from the farm gate to the consumer till it comes to the consumer. And then shortening the distribution chain by having more and more B2B ventures. One should try to reduce as far as possible the distribution cycle, distribution chain. Then value addition of fruits and vegetables like intermediate moisture food, high moisture fruit products, or their fermented products, or such other so many products. Then finally, and more importantly, you can say byproduct utilization, where extraction of bioactives, functional foods, preparation, etc. So, these are the areas, and these should be more and more explored. So, these challenges they offer the opportunity as they become opportunities in foods and vegetable processing sector. Okay. So, what should be done? That is utilization of the information knowledge generated through ongoing farm practices to develop novel technology, that is in the different parts of the country, what are the existing practices in the farm level, etc. So, that should be properly that is studied, and this should be used to develop the novel technologies at their company. And then finally, also further the application of novel technologies for enhancement of shelf life and adoption of zero waste or near zero waste processing strategy, that is one. Then the pilot studies, that whatever these technologies etc. are developed and on the basis of that is important is that the upscaling of the process. So, for that pilot studies, modeling and upscaling of the developed processes, and then I think there is another strategy, important strategy which should be adopted is the establishment of technology or product demonstration units and technology transfer, facilitation of the technology transfer. Entrepreneurship development and startup promotion is an important activity or area which should be encouraged, and then more important is that knowledge dissemination and awareness creation, that is farmers, consumers, processors, entrepreneurs, they should be informed. Some means should be used to communicate, and in fact in this course has been one such means where we try to disseminate the information to various users and various practitioners. Okay. So, ultimately there should be a holistic approach from farm to fork, starting from the harvest till it reaches the consumer, that is the post harvest handling, grading and sorting, okay, temperature control distribution system, computer vision system should be used, then pre-processing, processing and packaging here has up, and good manufacturing practices should be followed. Finally, the distribution, retail and consumer. So, each and every stage proper care should be taken, every possible effort should be taken to make sure that the product is safe and it is of good quality. Okay. Then the various aspects accordingly we covered in this course: novel and emerging methods and technologies of post harvest handling, transportation, processing and packaging of major fruits, vegetables, spices, plantation crop products were discussed, studied in the course. Even minimal processing strategies and such other methods of producing quality, ready to eat, ready to serve fruits and beverages, even hurdle technology concept for preparing intermediate moisture food, high moisture fruit products, dehydrated fruits, juices, pastes, okay, even fermented products from fruits and vegetables. Then various methods for extending the shelf life of whole as well as cut fruits and vegetables, such as CA storage, modified atmosphere storage, edible coating etc. were taught in this course. Also, we studied that environment friendly green technologies and approaches for reducing the carbon footprint in the environment by fruits and vegetable processing industries, that is novel approaches for the near zero waste processing and utilization of byproducts and waste streams into the value added product, okay, and ingredient preparations for food industry etc. were discussed, were studied, and the focus was on the creation of wealth from the waste or byproducts, their utilization. So, all these various aspects have been covered in this 12-week class. So, finally, there is the I will summarize that the course this by saying that there are 4 keys to success. These are in any food processing line, but particularly they are important in the fruits and vegetable or plantation and horticultural crop products by virtue of their nature, perishable nature, short shelf life nature. That is one is the processing, increase the level of processing. At present only 2.2 to 3% processed only. So, we have to take every possible effort that yes, increase the processing, convert them into value added product, then packaging and shelf life of the whole processed product and cut fruits and vegetables. Then a proper supply chain management should be adopted for storage and distribution. And then finally, equally important is the retail and marketing and retail, and where the entrepreneurship and startup promotion should be encouraged as far as possible. So, let me a little bit elaborate that entrepreneurship and startup promotion also. So, basically let us see what a startup needs. That is, it needs the customer know-how, that is who are the customers, what they want. Then there should be some capital, a startup needs capital, it needs sector knowledge, okay. Then the location etc. are some facilities, it needs some place, etc. Then other infrastructure resources, and finally a control over the information of the regulations, legislations, regulatory requirements, etc. So these are the information which a startup must generate before going to the business or startup. Okay, they should have a clear understanding of all these things. Okay, for setting up of a business, that is the step by step what are the requirements, that is one should have a clear business plan, then there should be appropriate or proper funding for doing that business, there should be products, operation, production line, even operation staff, that is operation lines, staff, machinery, etc. Then finally licensing and marketing. So these are the various one by one in the chronological order, the steps involved in the setting up of a business. So the business plan is a very, very important document for any startup or any to have some entrepreneurship activities, etc. So the business plan, what is that? It means of communicating your vision to the outside world to help you attract talent and money to your enterprise. That is, this is a plan, a document which tells that yes, the one who reads this document understands your vision. Okay. And the quality of a business plan is measured by its ability to hire employees, gain contracts from potential customers, and negotiate money investment from an investor who is interested in solely to make the profit. So what are the expectations from a good business plan? That it should be a well thought out document, and it could be easily visualized. So this should articulate the strength and the visions of your business. This should clearly outline the risk associated with this business, and it should present a clear evidence of the validity of the venture. So in fact, it should compel the action and get investors excited. The one who reads your business plan should get excited to get associated with your business in either in any form, either to fund, give funding, etc., or to join it in a suitable. Okay. Then there are various Government of India schemes, particularly in the past few years. Government of India has been very, very proactive. It is going out of the way to promote startup and entrepreneurship and develop activities, etc. It has introduced over 50 plus startup schemes in the past few years. Each startup scheme is missioned toward boosting the Indian startup ecosystem. Okay, and various schemes which are launched by the different government agencies like Niti Aayog, NSCI, NSIC, SIDBI, MSME, that Serve India, or Ministry of Food Processing Industries, AIM, or even Department of Heavy Industries. So various departments and ministries of the government, they even in agriculture, okay, Raftar scheme, NABARD is there, and they provide funding also in the agriculture and food startups, promoting seed money and other values are there. Okay. So to start up a business, food startup, food business, there are certain requirements like the licenses which are required. Number one is the, as I told you, FSSAI, food license. It is important and mandatory requirement. So for making a product processing plant, FSSAI provides licensing for that, doing that, and if one is not taking a license and doing the food business, heavy penalties may be imposed. So at this, getting license is easy. One can visit the FSSAI website, etc. All the details are available. Then one has to obtain the trade license. That is, food business is usually granted trade license as an eating house under the municipal corporation laws of the respective state in India. Then company registration of companies should be done at the registrar of companies or under the business SSAI at the local DIC office. Then GST registration, it can be easily done at the online websites. Then establishment registrations, every owner of a shop or commercial establishment having more than 10 employees must obtain a shop and establishment registration from the respective state labor departments. And then also another important NOC, that is the fire department no objection certificate. So, this NOC from the fire department is required to run the food business, and at present I think there is no fee requirement for taking the NOC. Okay. So, these were the, now let me briefly discuss about the food chemistry and technology laboratory to which we belong to. This is the website logo. You can, if you are interested, you can visit our lab website, okay, www.fctlitkgp.co.in. So, this is a research and development laboratory. We conduct research in the areas of, that is the new product development as well as process and machinery development. About on an average roughly 75%, that is the 3/4 of our activity in the laboratory is focused toward process and machinery development, and 1/4 is the new product development. If you look at the specific area, that is sector wise, crop wise, we concentrate around about 20-22% on the fruits and vegetable technologies, and about equally 21% on ready to eat sector, extrusion technology sector. About 30% we are developing functional foods, which again includes from fruits, vegetables, spices, etc., from the various sources, and roughly around 14% to 15% on the dairy foods, as well as extraction and purification of various bioactives, etc., from our ingredients from the various raw produces materials. Okay. These are some of the major products which has been developed into research in our FCTL laboratory at IIT Kharagpur. These includes various ready to eat products, algal food biotechnology, tea processing. We have developed, got a patent for that is the black tea or green tea, the green tea tablets, then antioxidants from various bacterial, then oil processing, ready to eat health foods, then this is the oat based ice creams, low cholesterol dairy cream, okay, black tea powder, green tea powder, probiotic vegetable beverages, then extruded traditional ready to eat snack foods or extruded traditional health foods, etc. So, various, and most of these, many of these are patented, or they have, some of these have also been transferred to various laboratories. So, we will take up at least some of the important processes R&D developed particularly in the last 5-6 years. Okay. We will discuss. There is one is the ready to eat therapeutic food, that is for the severely acute malnourished children. Okay. This is a patented process. It was also given Gyati Appreciation Award in 2018. So, what we do in this process basically, that is we are taking various locally produced agricultural material like peanut, soybean, maize, etc., and these are made to ready to eat farm by roasting, then grinding and de-skinning, converting it into the powder form. So, these powders, etc., are there, and also there is a roasted peanut paste. Peanut is converted into ground into the paste. So, roasted peanut paste, soybean flour or maize flours, etc. Then we are getting a vitamin and mineral premix, soybean or such other edible oil, sugar, okay, milk powder. Okay. So, this is in appropriate proportion. These are developed, and in fact, the final ingredient, that is these are the using linear programming or such other method. We have developed 5 formulations from these commodities, and each formulation that it meets the requirement set by the FAO or WHO for a severely acute malnourished child. So, this is finally packaged, or it is into a form, maybe that ready to eat form, it is in the ready to serve form in the plastic pouches, etc. So, that the mother cuts open these pouches and just feeds the child, because that severely acute malnutrition management is normally in the children which are of 6 months to 6 years. Okay. So, this needs no further preparations. Okay. It is in hygienic form, and it is consumed and liked by the children. So, this is one product which we have prepared. Then another important product which we have done, and again it is a patented process, it is the micronutrient fortified rice for mitigation of the anemia. Okay. And here we are using this extrusion process, because extrusion is considered to be the most promising technology, where the broken rice is taken, broken rice is pulverized, and in this vitamin mineral premix as per the FSSAI requirements, they are mixed, and then broken rice flour is set to this conditions and mixed with vitamin mineral. So, it is fed to the twin screw extruder, where this is given a shape of the rice kernel. We are getting that fortified rice kernel, all right, and these fortified rice kernel, then they are mixed into normal rice. There is we have a FRK normal rice mixing unit, which gives the fortified rice, that is of the required composition. So, this rice, fortified rice, has the level of raised level of added level of iron, folic acid and vitamin B12. Okay. And we have also established a pilot scale unit which has 100 kg of FRK production per day in our departmental premises. Okay. So, that is the fortified rice kernel manufacturing. Okay. Then the same pilot plant we are using, that is just by changing the dye. In earlier for the fortified rice kernel, we were taking the rice dye. Now, here the rice dye is replaced with a noodle dye, and we are giving that because these children are anemic children, etc. In India, that anemic children and ladies are more. So, children, anemic children, they may like to eat noodles more or the rice. So, the rest process is same, little there is a process parameters, etc. And one more thing also which we have done here, that we have also developed a process to replace the fortificant, that premix, that is we are using natural ingredients to increase the vitamin and mineral content in the fortified rice noodles, but it is also extrusion process, and the same pilot plant is used in this. Then the other is that low glycemic rice for diabetic persons. Okay. Here again, that using linear programming from various like low rice broken are taken, barnyard millet, and then foxtail millet and quinoa in appropriate composition and formulation. This is taken, milled, sieved, mixing, and we have a multigrain flour. And this multigrain flour, again it is a moistured conditions and fed to the same extruder, and where the rice dye is used, the dried and low GI rice. And this is good for the diabetic person, because here by having the proper combination of barnyard millets, etc., we are maintaining this glycemic index, low glycemic index, has more resistant starch content. Then another is the essential amino acid balance Nutri-Dal. Here in this, we are taking that as it resembles the natural dal. It is at a shorter cooking time and less anti-nutrient factor. It is also just in earlier case we are taking rice broken, here now we are taking the broken of various dal mill byproducts, and in the appropriate quantity they are converted into powder, and they are mixed in the appropriate quantity and fed to the extruder. So, we are getting that is the dal here, extruded dal, okay, from the natural dal brokens, and this dal is balanced in essential amino acid, its content, all the essential amino acids, that is which is as per the, and it meets that requirements, that is in the, if you take 100 gram this dal and 100 gram egg, their essential nutrient, essential amino acid composition will be comparable, similar to that. Then under it is the PUFA enriched vegetable oil powder, and this what we are taking, that here we are balancing the MUFA-PUFA ratio. We are taking, that is the sunflower oil, sesame oil, some other vegetable oils, and blending them into proper proportion, so that to have a maximum antioxidant value, maximum unsaturation level, and also a properly balanced MUFA-PUFA ratio. And in this certain wall materials are used, a homogeneous that is the emulsion is prepared, and this emulsion is finally either spray dried or microwave dried. We get that powder, and this powder now, that is oil powder which we take, this can be used in replacing the that is the other, normally that is fat, saturated fat, either in the bakery products or in the frozen dessert industry, and this gives a good healthy alternative to the saturated fats. Another is the microbiological microencapsulations of probiotic, the same, there is the probiotic bacteria powder, that is we are taking a GABA, GABA, gamma aminobutyric acid, which is a neuroprotectant, and lactobacillus plantarum. They were co-encapsulated using spray drying. Again here the bacterial lactic acid bacteria, GABA, and the wall materials are taken, a solution or emulsion is made, and then it is given ultrasonication, and finally this emulsion is spray dried or freeze dried. You get probiotic bacteria powder. This is the probiotic bacteria powder, and it has a very good stability, more than 2 years. Its CFU, that is bacterial count, is maintained even in the refrigerated conditions. Okay, and this probiotic bacteria count can be used in various bakery and confectionery product, in beverages, etc., to make that probiotic rich powder. Okay, so that there are other products, that is instant soluble milk tablets. Okay, where we have designed a milk tablet making machine, and this skim milk powder is taken, it is conditioned, compressed, and it is converted into SMP tablet, and these SMP tablets, it can be taken, and whenever required, it is a convenient way for carrying the milk powder, and whenever it is required, one can add into the gum. It has a good resolubility, and this idea, once it is done, now the next part is that even the antioxidant powder, the fruits and vegetable juice powders, they can also be tableted. Tea powder, we have got the tea, so it gives a antioxidant tablet, natural material. So that is one possibility. Then also we have membrane filtered and ozonized self-stable sugar cane juice, where you are using ultrafiltration and microfiltration processes to remove to filter out the bacteria, etc., which is present in the juice, and undesirable enzymes, etc., and then finally it is giving ozone treatment and packaging. So you can see here the raw juice and the processed juice, how clear it is, and it has a shelf life of about 3 months under the refrigerated condition. There are 6 log cycle reduction of bacterial count, 4 log cycle reduction in yeast and mold counts, almost a 97% reduction in polyphenol oxidase enzyme activity, etc. Then ready to drink green beverage. Here we are taking different roasted maize, Bengal gram, ragi, etc. They are ground, sieved, and colloid milling, and after that it is made into a slurry and then freeze dried. So is instantized grain mix we are getting, and in this grain mix powder, it is soluble grain powder, okay, mixed grain powder, and the probiotic, earlier we discussed, so that probiotic is added into this, and in a calculated amount we add water, and you get a probiotic grain beverage. Okay, this is under this carbonated amla beverage premix. In fact, this we discussed in one of the lectures in carbonated grain beverages during lectures. So that is, so many other such other fruits and vegetable products we had developed, which in various lectures we covered earlier. So this also, it is the amla is taken, hot water and microwave amla juice flour powder, and then finally this can be used carbonated, making carbonated. We also developed one carbonation powder. Similarly, even probiotic vegetable powder we developed. Okay, these are some of the publications of our laboratory food products and process in different, in the 2 volumes, and then functional foods. Okay, and many other lecture compendium, laboratory manuals, etc. we have published. These are available, soft copies as well as hard copies are available in that. Okay, then finally now I come towards a very, very important component of this today's part, which is my duty, that is to extend our acknowledgements and thanks to all those who contributed in this wonderful lecture, in this course, okay, in preparation of the course, etc. So first of all, I thankfully acknowledge the role of the teaching assistants. In fact, Dr. Chandrakant Genudal Bhagat, who is a project officer, he did PhD in food process engineering and MTech in dairy and food engineering from IIT Kharagpur, both with under my supervision, and was a BTech in agricultural engineering from Rahuri. Then other teaching associate is the Subham Mandilya, who is a Prime Minister Research Fellow, presently doing PhD under my supervision. He did a MTech again from IIT Kharagpur with me, and is a BTech from JNKVB Jabalpur. Mr. Siddharth Vishwakarma, another teaching assistant. He is a research scholar, Gyati awardee, okay, working for his PhD degree with me. He did also his MTech under my supervision at IIT Kharagpur, and BTech from JNKVB Jabalpur. So the contributions, as I told you, of these teaching assistants, and there are other PhD research scholars of the food chemistry and technology laboratory who contributed immensely in this course. Everybody's effort and contribution is thankfully acknowledged, and a special mention that is deserved, that is Ms. Mona Lisa Patnaik, Mrs. Jayashree Majumdar, Ms. Anjali Thakur, Ms. Nitya Michael, Mr. Saurabh Misra, and Mr. Anas Sheikh. So these again are the research scholars who are working with me for their PhD degree. They deserve a special mention. They also contributed immensely in the preparation of various lectures materials. So the teaching assistants and other PhD scholars, their contributions are thankfully acknowledged. Then I will be failing in my duty if I do not acknowledge the excellent job done by our IIT Kharagpur, that CEC, that video and lecture recording team, NPTEL team, and here that Mr. A.B. Ramacharolu, who is popularly known as Ramu. He is a project officer in NPTEL. He needs a special mention. I acknowledge his contribution in the video lecture and the recording. Thankfully, gratefully, I acknowledge. And all his team members like Rituparna Das, Susanto Mahapatra, Priyali Chakravarti, Saurabh Bhattacharya, Kajal Kumar Guha, Ajay Malik, Devapriya Chakravarti, they all, their efforts and this contribution which they did in the recording of this course is praiseworthy, and I, from course as a course operator as well as my team teaching assistant, I extend wholehearted thankfulness and gratefulness to all these video and lecture recording team. Okay, then finally also the NPTEL, that is these were the lecture recording team, and there are many other people who are involved in various operations in the NPTEL here at our Institute IIT Kharagpur, as well as in the National NPTEL and SWAYAM Implementing Institute IIT Chennai. So the IIT Chennai NPTEL team, IIT Kharagpur NPTEL team, and then finally IIT Kharagpur as institution, and the Ministry of Human Resource Development, Government of India, they who developed this unique portal, and who are encouraging, which is contributing immensely in the knowledge generation and knowledge upgradation in the country. And okay, and then finally I like to thank my department, Agricultural and Food Engineering department, for providing me this opportunity and for permitting to give this course, share this course, or to put in the public domain. Okay, I have tried my level best, my team has tried my level best to put as much as information possible in the public domain with this course, and I hope you will all have enjoyed this. Okay, so finally, wishing the participants of this course all the best for their future endeavors. Thank you and Jai Hind. Thank you.